Number 12 in 4.2 is asking us to find all the critical points of this given function here. So what we need to remember, I'm sure everybody has this in their notes right here, is that critical points can occur anytime that your derivative, which in this case I'll call f prime of t, is equal to 0, or anytime that that derivative right there is undefined. And with polynomial functions, we never really have to worry about polynomial functions being undefined, but here I've got a square root, and I know there are problems, guys, with the domain of a square root, so let's keep that in mind. But you'll notice, though, both of those come from dealing with our derivative. So the first thing we need to do right here is find f prime of t. Let's go get them. Derivative of 4t is just going to be a 4, and then this one's going to be a little bit tougher. Probably should have thought of this as 4t minus, and then a t squared plus 1 to the 1/2 power. So let's use the power rule here, guys. Bring that 1/2 out in front. That's going to be a minus 1/2. The same base of t squared plus 1, drop the power by 1, so that's a negative 1/2. But wait, there's more, times the derivative within. And the derivative of t squared minus 1 is going to be a 2t. Good old chain rule. So what can we do with that, guys? We can make this a 4 minus, and then I think a big fraction at the end of all that. Let's see, guys, I've got a 1/2 and a 2t. That's just going to give me a t up here in the numerator, and then a square root down on the bottom of t squared plus 1. So that right there is our derivative, f prime of t. And what we're interested in now is there any values of t here for which this derivative, back up to the top here, is either going to be 0 or is going to be undefined? Okay, so let's start playing around with that idea. First, let's worry about it equaling 0. 4 minus t over the square root of t squared plus 1. Well, let's see. If I wanted to solve this equation, first I'd bring the entire second term, which is currently negative, over to the right side. 4 then would equal t over the square root of t squared plus 1. Then I think I'd multiply both sides by that denominator and get 4 times the square root of t squared plus 1 is equal to t. Then, if I remember some Algebra 2 and some pre-calc here, to get rid of a radical, I would want to square both sides of this equation. I mean, they're both monomials, so that could be worse. On the left side, the 4 squared is going to get you a 16. The square root of t squared plus 1 is t squared plus 1, all of which equals a t squared. Okay, we're going to distribute that 16. We're going to get a 16t squared plus 16 is equal to t squared. And now let's move some terms around. T squared comes over to the left to give us a 15t squared. The positive 16 from the left moves to the right. Oh, to make a negative 16. Something just happened here, guys. T squared is equal to a negative 16 over 15. And now we would take the square root, there you go, of both sides of the equation. The problem is we're taking the square root of a negative number. That means that our only solutions for t would be imaginary. Now, I told you guys at the beginning of the year, we're not dealing with imaginary numbers in here at all. The point there is, guys, that imaginary numbers are not exactly what we're looking for. We're just looking for values within the domain of the original function, f of t, where that happens. So, oh my gosh, everybody, we did all that work, and guess what? There are no values of t for which your derivative is equal to 0 right there. So that was kind of a bummer. But there's a second consideration then as well. We also need to think about, I'm going to switch to purple now, I think. We need to think about, are there any values of t for which this derivative, which we had in the box up there, guys, let me come back to that, for which that derivative is going to be undefined. So what would make an expression like 4 minus t over the square root of t squared plus 1, what would make that undefined? Now, being undefined is weird. It's not a number the way that 0 was here. So I can't just start moving terms around and dividing by 4 or anything like that. So you kind of have to kind of freehand this one, at least mentally, and try to think about what would make this thing happen. Well, what makes a fraction undefined is if your denominator is ever equal to 0. If that happened, we would have 4 minus an undefined quantity, and that would be undefined as well. So what would make our denominator, the square root of t squared plus 1, equal to 0? Because if that happened, that would be what we're looking for. Well, if I squared both sides, I'd get t squared plus 1 equals 0. If I subtracted the 1 here, I'd get t squared equals -1. And if I took the square root of both sides, yet again here, guys, we'd end up with an imaginary solution. So it sure seems like, in looking at this, there are no values of t that we could come up with here, guys, that would either make our derivative 0 or undefined. Both of those kind of required us to come up with imaginary numbers. So it looks at this point right now like the answer to this is that there isn't a value that would do that. So in number 12, let's see right here, that is where we seem to be standing right now. And yeah, a quick glance at the solutions manual verifies that there are no values of t that will either make this derivative 0 or undefined. So the answer, after all that work, is a big fat no critical points for this particular function.